some quantities like speed. Okay, speed has only magnitude. So I'll just write magnitude. And then we have velocity. Velocity will have magnitude as well as direction.
Yeah.
Okay. All right. So now we can actually, okay, so vectors are what? Vectors are magnitude plus direction.
Yeah.
Now we can draw any vector on a two-dimensional plane. Okay. Okay. And one more thing is these quantities which do not have direction, they are called scalar quantities. So this speed is a scalar quantity. Okay.
Okay.
And quantity which has direction and magnitude, they are called vectors. So that's a basic difference between scalars versus vectors. Okay. Now you can represent vectors in a two-dimensional plane. You will see how you can represent vectors. So you have your regular x and y axis. Okay. And you can have your vector like this. Okay. This is a vector and it will have a name, like this is like a ray, you know.
Yeah.
You would have rays. Okay. So it will have an initial point and the terminal point.
Okay.
Okay. And it will have, let's say this is A, this is B. Okay. So this vector has a name. You can give it any name. Let's call it A. And if you draw a little arrow on the top of the vector, that represents that it's a vector.
Okay.
Okay. Now the next concept is, so if you have this vector and you want to find out its magnitude. Okay.
Yeah.
So in order to, now every vector.
And the magnitude is just like the length of the vector?
Yes, just the length of the vector. And you should know one thing, that every vector has two components. Okay, it will have a horizontal component and a vertical component. Okay, so this is a vector right now, A to B. It will have two components. I'll just for a moment, I'll erase this. Okay, so the horizontal component will be this.
Yeah.
And the vertical component will be this. So I will bring this. This A is just the name of the vector, and this is the vertical component. Okay. We usually denote the horizontal component by letter X.
Yeah.
And the vertical component by letter Y. Okay. And the horizontal and vertical components, they create a right angle between them. Okay. Now, if you have to find out the magnitude of this vector, it is denoted by, so I'm going to write this magnitude of vector A. Okay. It is denoted by absolute value of A. Either this, or you will also see double bars. This means this is magnitude of vector A. And it is very easy. You just have to find out the length from point A to B. Okay. So, you know, you can apply the Pythagorean theorem. That will give you x squared plus y squared.
And you have to write the magnitude like the double bars?
The final answer?
No, you have to write the magnitude with double bars?
Yes, that this notation represents magnitude. The double bars, between the double bars, whatever you have, that represents the magnitude. Okay. You're good so far?
Yeah.
Hello? Okay.
Yeah.
Now there are a couple of ways to represent or to write a vector, for example. So if this, you have this vector, you can write this vector as the horizontal component x, comma, the vertical component. This is one way of writing it. Okay. You can also write it as whatever is this point. Okay. X coordinate of this point, x2 minus x1. This will be x1. This will be x2. Okay. Comma. If this has vertical y coordinate, y2, and this is y1. So you can also write y2 minus y1. Okay, just different ways of writing a vector. Okay, now this is called your component form.
Okay.
Component form. These are just the notations. And another way of writing this is you can simply write A, B, and make an arrow on top of it. That also represents a vector.
Okay.
Okay. So I don't think we need to do questions to find out magnitude, right? It's very easy. You can find out the magnitude if I give you a vector.
Yeah.
So just quickly, if let's say you have a vector P, like in the first example, you have PQ. So you will be given the vector in this form. You'll have either coordinates of P and Q. So let's say P is 2, -3, and Q is -4, 4. P is the initial point and Q is the terminal point. You can find out the magnitude.
Mm. Yeah. So can we just like graph it real quick?
Yes, let's graph it. So just P is the initial point and Q is the final point. I think we should take the graphical background.
So 2, 3, 2, -3.
Wait. Okay, so 2, -3, 1, 2, and 1, 2, 3. This is P.
Yeah.
And so this is the initial point and Q is -4, 4. So 1, 2, 3, 4, 1, 2, 3, 4. This is the terminal point. Okay, so your
Wait, how do you
vector,
know which is terminal? The first point?
that's given in the question. That will be given in the question. This is the initial point.
Okay.
That will be given to you in the question. And this is terminal point.
Okay.
Okay, so your vector is going to be this. Okay, so first of all, you need to identify the horizontal and vertical components
Hmm.
of this vector. Okay.
So we can use the distance formula, right?
Yes, you can use the distance formula as well, but yeah, you can use the distance formula,
Or
but
we can do the horizontal component and the vertical
that's what
component.
I said. That's what I said. That's what you should do. You should find out the horizontal component and the vertical component. So this will be the vertical component,
So
and
that's
this will,
7 and 8.
so this
No, 7
is
and 6.
4 and 3, 7. That's the vertical component, and this is 4 and 2, 6.
Yeah.
Okay. Okay, so you will write. So your vector is PQ, and remember when you're writing the name of the vector, first you will write the initial point. So P is the initial point, so that will come first. We will not write QP.
Oh, okay.
Okay, we will not write QP. We'll write PQ. Okay,
Okay.
so to represent the magnitude, you put it between the double bars. PQ, draw an arrow on the top and put it between the double bars. Okay, now can you write it in the component form? So in the component form, this was a component form. This is called the component form.
Okay.
Okay, so this is important. Writing it in component form, you will write it as, first you will write the horizontal components. Okay, Kailash, now understand this thing. When you're standing at point P and you have to go to point Q, you're moving here in the left direction, and then you're moving up. This is how we understand the components. First, you're moving left by 6 units. So your horizontal component is actually -6 because you're moving left. So one more thing is with vectors, the left direction is associated with negative sign.
Mm.
Okay, wait. Just how in the number lines, when we're moving left, you have negative numbers. So left direction is negative, right direction is positive, and vertically, if you're moving up, then that is positive, and if you're moving down, that is negative. Okay?
Yeah.
So in this case, your horizontal component is not 6, but it is -6, right? -6. And the vertical component is +7. So this is the component form. So, okay, now this, here you will not write the double bars. This is your vector. Now to find out the magnitude, you put it between the double bars and you take square root of negative 6 square plus 7 square. Okay.
Yeah.
Okay. So this is easy. And so that will give you square root of 36 plus 49.
Yeah.
That will be 965,437 plus 1, 885. Square root of 85 is the magnitude. You can further simplify it. Okay.
Mm-hmm.
This is easy. Magnitude of a vector. Okay.
Yeah.
Next concept is the concept of opposite of a vector, or just an opposite vector. So just imagine that you're moving in a certain direction. Let's say you are moving like this. Okay. And so you are here, and there is your friend who is moving in the opposite direction. So both of you were here. You started moving in this direction, and your friend started moving in the opposite direction. But both of you traveled the same distance. So if you traveled, let's say, 100 meters, your friend also traveled for 100 meters.
Yeah.
Both of you traveled in the opposite direction. So your vectors, your vector and your friend's vector, they are called opposite vectors. Okay. Because, so just remember, the magnitude will be same, but the direction will be opposite. So let's say this point is A, this point is B, this point is C. So you have two vectors, AB and AC.
Yeah.
Okay. And they are opposite of each other. So if I write AB is equal to negative of AC, that just means that these are both opposite vectors. Okay. And now one interesting thing will happen. The components, if I make the components, let's make the components. So for your vector, for AB, this is the horizontal component, right?
Yeah.
Wait, it's not. Okay. This is the horizontal component. And for your friend, this is the horizontal component. So whatever this is, whatever unit, let's say this is X. So for your friend, this is negative X. Okay. And your vertical component is this Y. And for your friend, the vertical component is this negative Y.
Yeah.
Okay. So what we usually do is we give both the vectors same name. We call that, let's say, your vector is A and your friend's vector is also A, but we will write a negative sign in front of it. Okay. And
Yeah.
if your vector, if I write it in the component form, it will be written as X comma Y. Your friend's vector will be written in the component form as negative X comma negative Y. Okay. Negative just means that the direction is opposite. Okay, so will there be any change in the magnitude? If you find out the magnitude of your vector and your friend's vector, will you get different magnitudes?
No.
You'll get the same magnitude.
Yeah.
Exactly. So that's an important observation. Even though the vectors are opposite, but your magnitudes will be same. Okay, the next concept is the concept of a unit vector. A unit vector is just a vector whose magnitude is 1.
Okay.
Unit means 1, right?
Yep.
Okay. Okay, so unit vector, a vector whose magnitude is 1.
Mm.
Vector whose magnitude is 1. Now, if you have to find out the unit vector of a particular vector, so what do I mean by that? Let's say we have a vector u, okay? We want to find out its unit vector,
Yeah.
okay? So how will you find out its unit vector? Okay, you also need to understand this. Let's say u is this. This is u. Now, when I say I want to find out its unit vector, I mean to say find out a vector which is along the same direction. It is in the same direction, but its magnitude is 1.
Yeah.
Okay. Okay. So we have a formula to find out a unit vector of a particular vector. It is
Yeah.
given by, you just take the vector and you divide it by its magnitude. Like take the components of u and divide it by its magnitude.
Yeah.
That will give unit vector. So that will give you unit vector of u.
Yeah.
Okay. So let's say you have a vector a and it has the coordinates -3, 6. The components, I mean. Okay.
Yeah.
We have to find out its unit vector. That means we have to find out a vector which is along the direction of this vector, but it
Hmm.
has a magnitude of 1.
Yeah.
Okay, so find its unit vector. So the formula, so you will write unit of a over magnitude of a. So first step will be you'll need to find out the magnitude of a. Can you find out the magnitude? -3 square plus 6 square.
Yeah. So 9 plus 36, 45.
45. And 45 can be written as 15 times 3. 15 can be written as 5 times 3. So this will be 5 will be inside 3 root 5.
Yeah.
Okay. Now, using this formula, your unit vector A will be, you take -3, divide by magnitude 3 root 5, and then take the vertical component 6, divide by magnitude 3 root 5. So you can
Yeah.
simplify this. You'll get -1 over root 5 and 2 over root 5. This is the unit vector
Yeah.
of. Now, if you find out its magnitude, like you can verify your answer, you can find out its magnitude, you will get 1.
Mm.
Okay, if you want, you can verify square root of -1 over root 5 square plus 2 over root 5 whole square. This, when you simplify it, you will get 1. That means this is a unit vector and it is along the direction of this vector. Okay. Okay, now comes the real thing. You can also represent the components of any vector
Mm-hmm.
if you know what angle the vector is making with the x-axis. And this is basically, you've done this already. So let's say we have our x and y axis and we have a vector. Okay. Now let's say we want to find out the components of this vector, but we don't know the coordinates. Okay. We only know the direction. The direction this vector is making with the positive x-axis. Let's say this is making direction theta. Okay. And you know what is the magnitude. Let's say the magnitude, usually the magnitude is represented by r, a number r. Okay. Now let's say you want to find out the vertical and horizontal components. This will be the vertical component and this is the horizontal component. Sine, we know that sine of theta is going to be y over r, opposite over hypotenuse. So y will be equal to r sine theta.
Mm.
And we know that cosine theta will be equal to adjacent over hypotenuse, so x over r. So from here, x will be equal to r times cosine theta. Okay?
Mm-hmm.
Okay. Okay, so this was one thing, that if you know the magnitude and you know the angle that the vector is making from positive x-axis. So how can we find the components? Now you can also write this vector in the component form. Let's say this is A. So you can write A as r cos theta, comma, r sine theta.
Mm.
Okay. Now we'll do the opposite. Let's say we know the components, but we want to find out the angle. So how can we find out the angle? And we don't know the magnitude, let's say. Now we don't know the magnitude. We know x and y, and we want to find out the. So with theta, you get the direction, like in which direction somebody is going. If you know this angle, this theta tells us the direction of the vector.
Yeah.
Direction of the vector. So let's say now we know the horizontal component and the vertical component. And from this information, can we determine the value of theta? Okay.
I
So can
mean,
you
we can do like the inverse, right?
verse? Yes. Okay. So which ratio you will use? Which trig ratio?
Tangent.
Tangent, exactly, because this is opposite and adjacent. So we know that tangent of theta will be in this case y over x.
Mm-hmm.
Theta will be tangent inverse of y over x.
Yeah.
Okay. All right. So now, you can be given any information. You can be given the components or the direction or the magnitude or
Mm.
combination of these. And you will be asked to draw a sketch or find out some missing quantity. For example, let's say you want to find the direction. Okay. And its components are, find the direction of a vector whose components are
Yeah.
given. Components are, it's in negative 4 comma 7. Negative 4 comma 7.
So we can find the magnitude. Wait, but we need to find if it's like north, east, or west, right?
Yes, so whenever you see that you want to find out the direction, that means you want to find out the angle that the vector is making with the x-axis.
Mm.
So what we really need to find out is what is the angle the vector is making. And now in this case, when the components are negative 4 comma 7, that means negative 4 will be here, 1, 2, 3, 4, and 7 will be here. So your vector, like the terminal point of the vector is this.
Mm.
This point is negative 4 comma 7.
Yeah.
Okay, so so this point is what? This point is, what are the components? R cosine theta, comma R sine
Sine.
theta. These are the coordinates of the point. Now you have components always mean that they are the terminal point, the coordinates of the terminal point.
Mm-hmm. So.
Okay, so your vector is like this.
Mm.
We need to find out what is this angle.
So we can do tan of 7/4.
Negative 4. So theta will be tangent inverse of 7 over negative 4. And you can always use your calculator to calculate this value.
Mm.
Tan inverse of 7 over negative 4, negative 60.26.
2.6.
So this negative means what? This means negative means what? That it had moved in the
Opposite.
negative. So negative 60 means that when you were standing here, you started moving here.
Mm.
Negative means clockwise direction, right?
Yeah.
So that means you have gotten this angle.
Mm-hmm.
This angle. But you need to find out this angle. So how will you find out this angle?
180 minus that.
Exactly. So your final answer will be This is not the final answer. You need to do 180 minus, what was it, 60
Negative
times.
60, right?
No, now we have taken that negative just means that the direction is clockwise,
Oh, okay, okay.
right? So this angle is of 60 degrees, but in the clockwise direction. So I'll make this arrow, this arrow.
So it's 119.74.
Yeah, 119.74 degrees. That is this red angle.
Yeah.
Okay. And one more thing is, if you want to write north, east, west, south, so this direction is this, you know that this is north and this is west, this is east and this is south. So this vector is, we'll say it is in the northwest direction.
Mm.
Between north and west, we say northwest, or we also say north of west. Okay, north of west. You're good so far?
Yeah.
Okay, now we will do some questions in which the direction will be given and you'll have to sketch the vector. Okay,
Yeah.
so first, there is a vector 50 degrees south of west. We have to sketch it, south of west. So you should mark the direction to this north, south, east, and west.
Mm.
Okay, now whenever you have these type of questions, what you will do is you will have to start with the west direction. This will be your starting point.
Yeah.
Okay, and this is, you have to move in the south direction. So move in this direction. So that means you will start from west. So you'll start from here. You will not start from here. And
Mm.
obviously, south of west means it will be between south and west.
Yeah.
Okay, you will start from here and move down. So somewhere here.
Okay.
This is your vector, and 50 degrees south of west. So where will be your 50 degrees? I mean, what will be your,
Southwest. So
this is your
yeah,
50 degrees.
yeah, that.
But what will be your theta, like your actual theta? By actual theta, I mean this total angle.
Mm.
Remember, this 50 degrees is only this part.
Yeah.
But so theta will be this portion, that is 180 from here to here. This portion is 180 plus 50. So it is 230 degrees.
Yeah.
Okay. Okay, let's do one more. 22 degrees west of north. And I will copy and paste this. Okay. North, south, east, west. Okay. West of north. So you have to start.
So 72 degrees left in the y-axis.
Yes. So between north and west. So
Mm.
now this portion, this is 72 degrees. And actual theta is going to be this entire angle. That is theta. So this will be, theta will be, this portion is 90.
So 162.
Yes. 90 plus 72 is 162 degrees. Okay, one last. 15 degrees east of south.
15 degrees east of south. So it should be 15 degrees to the right of the bottom y-axis.
This is S, this is E. East of south, so it will be between east and S. It will be in the fourth quadrant. Now 15 degrees is very less. So you know you also have to draw approximate degrees, like so you're starting at S and you're moving 15 degrees. So 15 degrees is very less.
Yeah.
So this is the vector.
Yeah.
Okay. And your angle, what will be your angle? So starting from here, this is the reflex angle.
Mm. So 285.
285. So 270 plus 15, 285 degrees.
Yeah.
Okay. Okay. Next, now we know the magnitude of a vector is, let's say, 12, and its direction is 210 degrees. We have to find out its components, and also we have to sketch the graph. So like perfect sketch we have to do, not a rough sketch, but a perfect sketch.
Mm.
Angle you will not be able to draw perfectly, but the length of the vector should be perfect. This, I'll draw the axis.
So
Sorry.
it's quadrant 3. So and
Quadrant.
it's 30 degrees.
Okay. 30 degrees in
Quadrant.
the third quadrant.
Yeah.
Okay. Now the question is, so we know that it will be here,
Mm-hmm.
but should I make it this much longer? Now I know that this direction, I know it is going to be 30 degrees, but should I make it this long or this long or this much long? That's,
You have to calculate it, right?
so how will you decide that how much longer should we draw it?
12 cosine 210 and 12 sine 210.
Exactly. Or you can just draw 12 units. This length will be just 12 units, right?
No, because that's just the distance.
So that is exactly what 12 is. The length between the initial point and the terminal point, that is what is your magnitude.
Yeah.
So if you have to draw it, now you won't be able to measure how much is 12. So that's why you'll have to find out the components. But if you just write 12 here,
Mm-hmm.
even then it will work. But let's also find the components, because we have to find the components as well. So components will be 12 cosine 210 and 12 sine of 210 degrees.
So 12 cosine is negative 10.39.
Hmm.
And the sine is negative 6.
Yes, so now you can plot the exact components. I'll get the grids. Okay, so negative 10, that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, comma, this negative 10 point, approximately 4, negative 10.4, somewhere here.
Yeah.
Comma negative 6, 1, 2, 3, 4, 5, 6, that is 6, this point. This approximately here. So you can now draw the vector. And now if you really take a scale and measure this ray from this point to this point, you'll get 12.
Mm.
If you actually take a scale and you measure this point to this point, what is the length? That will be 12 units.